Multiplying fractions is first up, and we've got two mixed numbers here. And before we do anything else when we're multiplying fractions, we need to convert those into improper fractions. So we've got 3 times 2, which is 6, plus this extra 1 lying around here, which gives us 7. So 3.5 is the same as 7 halves. And I'm going to multiply that by the other fraction, which also needs converting. So 1 times by 7 is 7, plus the 4 on top gives me 11. This is 11 sevenths. Now, at this point here, if you're familiar with cross-cancelling, you could just cross these 7s out because they're going to cancel out with each other. But if that's not the way you want to go about it, and I'm just confusing you, we'll just do top times top and bottom times bottom. So 7 times 11 gives us 77, and 2 times 7 gives us 14. We want to return that to a mixed number though, so we can either cancel this as we look at it now, and work out what goes into 77 and 14, or we can return it to a mixed number first. I'm going to turn this into a mixed number first by just finding out how many 14s go into 77, and I know that that's 5, and then I've got 7 left, so that must be 7/14. We're not finished though. You always need to check to see if this fraction will simplify, and it does. 7/14 is the same as a half, because 7 goes into 7 once and 7 goes into 14 twice, so it's 5.5. Next up is how to divide fractions. It's just a fairly similar process. So again, we need to begin by turning this into an improper fraction. So we've got 6 times by 2, which gives us 12, plus this extra 1 here, we've got 13. So we've got 13 halves over here, and we'll do the same on the other side. 1 lot of 7 gives us 7, plus the 6, we've got 13 sevenths over here. And we're going to divide those two fractions. The simple rule to remember when dividing two fractions is that you turn this symbol into a multiplication, and we can flip this second fraction, and it's always the second fraction. So first fraction remains the same, and I'm going to turn that into a multiply, and then flip this fraction here. So 7 and 13. Now, again, if you're familiar with the art of cross-cancelling, I could just cancel these 13s out here. But if I'm going to confuse you by doing that, just ignore me. So 13 times 7, top times top, gives me 91. And on the bottom, 2 times 13 gives me 26. Again, ideally I'm looking for this to be returned to a mixed number, so I need to work out how many 26's go into 91, which is 3 whole ones, because 3 lots of 26 gives me 78, and I've got 13 left over. So 13 out of 26. Again, not quite finished with this, because 13 out of 26 is the same as a half, and I always need to make sure I'm trying to simplify what's left, and I can do again here. That is 3.5. The important thing to remember when adding and subtracting fractions is that you can only do it when they have the same denominator, and that doesn't have to be the case when you're multiplying and dividing. Now, when you're adding and subtracting, you don't actually have to turn them into improper fractions first, although it's often a good habit to get into. You could just do 1 add 4 and then work out the fractions separately, but I'm going to convert these into improper fractions, and we're going to go that way. So 1 times 7, 7 plus 5 gives me 12, so I've got 12 sevenths over here, and then 4 times 3 is 12 plus 2 gives me 14 thirds over here. Now, remember what I said, you can only add and subtract fractions when they've got the same denominator. So we need to find a number that 7 and 3 both go into, which is going to be 21. So I need to turn 12 sevenths into something out of 21. Well, to do that, I need to multiply it by 3. So if I do the same to the top, I've got 12 times 3, which gives me 36. Now I need to do the same thing for 14 thirds, which needs to become something out of 21. And to do that, I need to multiply it by 7. So if I do the same to the top, I get 14 times by 7, which is 98. Now I've got the two fractions that I can add together. So I've got my 36 over 21, and I've got my 98 over 21. And I can just add these together. So when I do that, I've got 36 add 98 on the top, which is 134, and it's still going to be over 21. Final thing to do is to reduce that into a mixed number, because we don't like to leave our answers as improper fractions. So how many 21s go into 134? Well, 6 times 21 is 126, so I can get full 6 ones in there, and there must be 8 left over. So 6 and 8 over 21. And I know that the 8 over 21 can't cancel, so we must be finished there. The process for subtracting fractions is exactly the same as adding, and again you could sort out the whole numbers first here and then the fractions after, but I'm going to keep with the same format and turn these into improper fractions first. So 5 times 2 is 10, plus the 1 gives me 11 halves, and on the other side we've got 3 times by 5 is 15, plus the 2 gives me 17 fifths. When you're adding and subtracting fractions, you can only do it if they've got the same denominator, so we need to make sure these have got the same denominator. So 11 over 2 is going to become something over, well, we need to find a number that 2 and 5 both go into, and the logical one to choose is 10. So to do that, I'd have to multiply the bottom by 5, so if I do the same to the top, I get 55. Let's go and do the same thing to 17 fifths, which needs to become something out of 10. To do that, I have to multiply the bottom by 2, so if we do the same to the top, that gives us 34. So now I can just go and add together those two fractions that have now got the same denominator. So we've got 55 over 10 added to 34 over 10. And when we add those two things together, that gives us on the top 89, and that's 89 lots of 10, 89 tenths. So final thing, as ever, is to convert it back into a mixed number. So how many 10s go into 89? That's 8, and there are 9 left over, so that's my 9 tenths that are left over. And as usual, I check to make sure that this can't be simplified, and it can't, so it must be finished.